Hi students, I am Dr. Badrinath. In this video, we will see the infrared spectroscopy only introduction. Only introduction. You just observe, you listen, take a screenshots. Okay. And infrared spectroscopy, the two important features are there. One is we actually, apart from pharmaceutical usage, we are already using in our daily life, like a wireless mouse to a laptop that works under the system of IR rays only. TV remote and TV. The relation between a TV and a TV remote is the infrared rays. Okay, we are using in our daily life as usually, but that is one of the special important thing of infrared spectroscopy. See the fingerprint. Infrared spectroscopy is also called as a fingerprint region. Fingerprint region. Why we are calling it as a fingerprint region? Very interesting. Okay. Now we will see the topic. See, yeah, here you can see the fingerprint region. This you concentrate on this, my cursor. The 1000 to 450 to 500 centimeter inverse, that is a wave numbers. Keep in your mind. I will explain you later what is a wave numbers. Wave numbers range of an infrared spectrum is called as a fingerprint region. In this region is number of times it was appeared in competitive examination. Almost you can remember simply 1500 to 500. Only one is the difference. Like that you can remember. Okay, very simple. Approximate values 500 to 1500 centimeter inverse wave numbers. Okay, like you can remember. Why we are calling this as a fingerprint region? This region, see here, this region of the spectrum is almost unique for every given compound. Every given compound, either pharmaceutical compound or other compound, either API or drug, whatever it may be, excipient also, anything, any solvent or any powder, excipient powder or gaseous molecules will show a unique. Unique means it is only for that only, just like a fingerprint for a human beings. Fingerprint cannot match. That is the God's creation. Okay. Even for the twins also. See, identify the twins, these two. Okay, we cannot identify by seeing them directly. It is not possible for a human being. See, all they having a same characteristics, all organs, everything, but fingerprints are different. Keep in your mind, very, very important thing. Fingerprints of the twins also varies. See how the difference, with the help of that difference, we can find who is who. In the same fashion, see here, geometric isomers. Cis-2-butane, trans-2-butane. Geometrically, it looks like a same. Only the difference is CH3, even chemical molecule, chemical structure, molecular weight, everything is same here. Only the thing is you can the structure, 3D structure. Here H and CH3 are reversed. See here, CH3 and H. Cis means same side. You can keep in your same. Cis means same. Trans means opposite. So CH3 and H were reversed here. The remaining same is even bond length, length of the bond, okay, structure, atomic weight, molecular formula, everything is same, just like a twins. You cannot remember, but it is possible in the infrared region. IR region, infrared region. Keep in your mind, that is very, very important. So that's why we are calling it as a fingerprint region. Okay, that is a speciality of the IR spectrum. This is the complete electromagnetic spectrum. Complete. See here, this electromagnetic spectrum or electromagnetic radiation waves. No. What is the speciality? These waves cannot travel straightly. That is the thing what you have to keep in your mind. Always they travels in the wave like a motion. See here, doesn't travel straightly, always travels like this, like a wave. Laser light travels straightly. You are using, no, regularly we are using the laser light. It travels straightly. There is no bending, such a type of things, nothing. Okay. And here in the electromagnetic spectrum, this is the order, complete order you have to keep in your mind. Okay, here you can see almost all we are using these things. See, gamma rays we are using in the radiation, radio pharmaceuticals you will get. Here X-rays we are using in the diagnostic centers, X-rays. And these are the ultraviolet rays, UV rays. UV spectra I have already completed and watched my videos. And visible light, VIBGR, white light is converted into 7 lights like a rainbow and all that also I have completed. Only human is limited to this area, visible light. And infrared, see here remote I mentioned here, remote. Okay. We are using TV remote and all, it called as a IR only. Microwaves for the to heat. Okay, if you want to cook your puff, egg puff, veg puff, if you want to cook or heat it, okay, microwaves we are using. See here, these stoves we use it to see regularly on roadside, radio waves. Okay, like that. See, when you are coming here, you can get the short wavelength, here longer wavelength. As go on increasing the wavelength, energy falls. Wavelengths longer, energy falls. That you have to keep in your mind. Okay, the visible light only the human being can see, and here all these things, the devils they may see. Devils are beyond the animals may see, or God, that is beyond their science. Okay, they can see directly also, but for human beings it is not possible. Infrared spectroscopy is also called as a vibrational spectroscopy. Why? Why means there is a vibration. When you make a IR rays to fall on the molecule undergoes some vibrations, like a cell phone. Cell phone shows some vibrations, no? Same passion, inside the molecule, we cannot see that vibrations. We cannot see. Inside the molecule, molecule undergo the vibration. See here, this is the H2O molecule, water molecule, HHO. When your molecule undergo the vibration, see here how H becomes closer to oxygen, and sometimes it go longer also. It comes longer. When that depends upon how you are making the IR rays to fall on it, isn't it? So it undergoes some set of vibrations. That's why molecule undergo the vibrations after absorption of the IR rays. That's why it is called, only IR is called as a vibrational. Only IR is called as a fingerprint region. Okay. And infrared rays is also called as a heat waves. Heat. Generally, IR is nothing but a heat only. Infrared is nothing but a heat. But we cannot feel that. When IR rays falls, no, we cannot feel it heat. Light heat will be there. Okay. But we cannot feel it. Here the reason why infrared are called as a heat. See here, all these are the IR rays from the sun. Sun is a very good source, natural source of the IR rays. Sun is the source of visible rays. Sun is the source of UV rays. All three rays is hats off to the sun god. And when the materials are exposed, infrared radiation, water molecules of the material, any material, see here, any material, even on the earth or here, whatever it may be, absorbs this radiation. This results in the increase of the thermal motion of the water molecules in that material. Water main the thing, it absorbs the heat, that we know very well. Same thing was there. So that's why it is also called as a heat waves. And IR means infrared, inferior than the red rays, but not red rays. Most of the students, they are confusing in the exams. They are writing that infrared rays means it consists of a red rays. No, it doesn't consist of red rays. It is a inferior, below. Energy levels are below, longer wavelength than the visible region. They are not red rays. Please don't confuse. Red rays comes in the visible spectroscopy only. Color spectra, entire color spectra, colors comes under the visible only. Okay, no color. Beyond that, no color. IR rays are longer wavelength and less powerful energy than the red rays. that inferior, no, energy levels are less. So automatically longer wavelength step will be, one step is here and another step is that side, very longer. In Mysore Bonda, Mysore is there. Here you can see any Mysore here? No. In the same fashion, infrared name itself consists of a red, but no, name consists of red. Okay, but there is no red. Just like a example of Mysore Bonda. Here there is no Mysore in the Bonda. Okay. Here you can see where when white light falls on the prism, glass prism, VIBGR comes. See here, this is the order. This VIBGR, you cannot change the order. You cannot change the nature. Okay. Visible region 400 to 800 approximately. Ultraviolet means superior than the violet. That's why it is called a ultraviolet. But it also doesn't consist of violet rays. Infrared, see here below the red. This is superior on the top. Here it is below the red. That's why it is called a inferior. Wavelength is 800 to 1000 wavelength. Wavelength. Okay, but here we are using a term of wave numbers also in IR concept. That I will explain you now. Okay. In IR region, again it is divided into three. One is near infrared, mid infrared, and far infrared. Near, mid, far. Near means not to your house, not to my house, not to Taj Mahal, or not to any temple. Okay, it is a near infrared, near to visible. That's why we are calling it as a near. In the exam, don't write like that. Near infrared or near to my house. Okay, mid infrared, medium distance. Medium distance for visible. It is a standard here we are taking. Far, very far. Far rays are there. Okay, and this is a wavelength already, in the electromagnetic spectrum I have already shown wavelength is increasing in such a way and frequency energy is increasing in this way. Both are inversely proportional. So in the examination, they might ask what is a wave number, near IR, mid IR, far IR. This you have to practice and very easy to remember also. 1000, see, almost 1 and 4 are the common digits here. 14, 4, 4, 4, 4, 1, like that. Centimeter inverse is the units to measure the wave numbers. Okay, and wavelength. Wavelength also sometimes they might ask. Generally, they will ask the wave numbers only. These are wavelengths need not to be practiced. Okay, and energy. This is a high energy. See here, higher the wave number, higher the energy. Wave number, not the wavelength. See here, wavelength. This wavelength is inversely proportional to this column. Keep in your mind. See my cursor. Inversely proportional. This is directly proportional. Like these two keep in your mind. Right? Now we come to the important features of the IR spectroscopy. The most important thing is in UV, we are measuring a wavelength. UV, visible, whatever it may be. In IR, we are using a wave numbers. Wave numbers. Keep in your mind. Very, very important thing. See here, I will show you the graph also. This is the UV graph. X-axis observe. Here I mentioned lambda. Lambda means NM. That is lambda means wave length. Here we never take a wavelength. We are always taking the wave numbers, wave numbers, wave numbers. That is nanometers. See here, nanometers in the centimeter inverse we are using. That you have to keep in your mind. Wavelength we are not using. We are using the wave numbers. You have to mention the centimeter inverse there. Okay, don't mention wavelength in IR spectra. Here I have shown both as a wavelength. So this is, you consider it as a wave numbers. Centimeter inverse is the units of this. And x-axis. Y-axis, here we are using absorbance. Here we are using a transmission. Absorption, transmission, both are reverse. Absorption means how much it is absorbed. Transmission means how much it is passed. Here we are measuring the percentage of absorbance. Here percentage transmission. That's why here you will get a peaks. See here peaks. Here you will get a reverse of it. Halos. Because transmission, no? Transmission. That's why you will get a halos. Here and baseline. See, this is the baseline here. Baseline starts here and increases. Again baseline, again increases. You will get a peaks. But here baseline is at the top. See here, it falls down and again it comes to the base and falls down, again it comes to the base. So baseline is at the top. We are measuring transmission only. That's why we are getting a halos. They are absorbance. That's why we are getting a peaks. Okay. You compare that, you see the number of IR graphs and always write wave numbers on the x-axis of the IR, right? Generally. Okay. Yeah. Now you come to the spectroscopy, total entire spectroscopy, any visible or whatever it may be, any spectroscopy based on two things. One is absorption spectroscopy, emission spectroscopy. In absorption spectroscopy, how much energy is used by the electrons to jump from a ground state to excited state, that we are measuring. If you are measuring the compound by using that how much absorption of light, then you can say it is absorption spectroscopy. But some spectroscopy, it measures the emitted radiation. See here, the electrons in the which is present in the excited state, it comes back to the ground state by emits the radiation. That emitted radiation we are measuring. Then you can say it is an emission spectroscopy. These are the two basic principles. If you are measuring the how much light absorbed, that is absorption spectra. How much energy is released from the molecule, if you are measuring, then it is called a emission spectroscopy. Here I will show you the example. Yeah, absorption spectroscopy, analytical technique which concerns with the measurement of the absorption of electromagnetic radiation absorption. Example is UV, visible, IR. IR is also absorption spectroscopy, not emission. Okay. Absorption spectroscopy is again two types. Either that absorbed energy, either it is by the atom or by the molecule. Okay. Atomic spectroscopy. Here the changes in the energy takes place at atomic level. Then we can say it is atomic absorption spectroscopy. Atomic absorption, flame photometry comes under that only. Okay. Energy takes place, changes are takes place in the atomic level. The changes, if it takes place at a molecular level, then you can say it is a molecular spectroscopy. UV spectroscopy, see here, UV spectroscopy, colorimetry, that is visible spectroscopy. Infrared spectroscopy comes under the molecular. So infrared comes under absorption, infrared comes under the molecular absorption spectroscopy. Now emission spectroscopy, analytical technique which emission is dispersed according to the some property of the emission, and amount of dispersion is measured. For example, very good example is mass spectroscopy measures the emission. Here you can see the definition. Now I will come to the definition. It is a branch of science that deals with the study of the interaction of your matter, either the drug or whatever it may be, with the electromagnetic radiation. Is called as complete spectroscopy, not the IR. Any spectra, light will be there. You have to make the light to fall on the molecule or to fall on the atom. Okay, then how it reacts, how the atom reacts, how the molecule reacts when you make to fall on a light on the spectrum. Okay, this is electromagnetic radiation that I have shown. No, electromagnetic radiation definition. It consists of a discrete package of energy which are called as a photons, not photo, photons. Okay, photons is nothing but energy packet, like our purse packet. It is an energy packet. Yes, photons are nothing but energy packets. Okay, it consists of oscillating field, oscillating magnetic field. That's why it is called electromagnetic radiation. The oscillating photon, it consists of two properties: electric properties, and also magnetic properties. That's why electro magnetic radiation we are calling it as. And here you can see the what is that at your 10th class level or intermediate level, frequency. What is a frequency? How many cycles per second is also measured by the Hz. 20 hertz to 20,000 hertz we are able to hear. Okay. Bats listen to up to 2 lakhs. 2 lakhs hertz also it is able to. Wavelength. Wavelength, here you can see what is the length of the wave. Same length of the wave. I already told, no, this is a wavelength. In electromagnetic radiation, that rays doesn't travel straightly. I have already told. Like this. This is a laser light, means at the center straight it go. Laser light. Here, wavelength from one wave to peak of another peak of the wavelength is called as a wavelength. Okay. The relationship also here I have mentioned between the wavelength and frequency. Okay. C is equal to V and reversed V, that is lambda. A photon is subjected to energy E is equal to hv. Here, what is the difference between the wavelength and the wave number? See, one peak to another peak, that I have already mentioned, that is a length. Now, in one unit area, how many waves are there? See here, you take the example of P. See, P, I started here and I ended here. How many waves are present in the unit length is called as a wave numbers. See here one is there, here more than one, here almost two is there, here 2 plus is there, here how many see? 1, 2, 3, 4. Okay, 4, more than 4 are there. These are the wave. Okay, these are the low energy violet VIBGR. Here also you can see VIBGR. Okay, VIBGR it. See, red light travels fast. That's why we are using a red light as a danger light. It reaches to eye hour fast because steps see here. Here one step and here one step it is putting and here one step. It comes very fast. Okay, but energy is less when compared to the violet. It has to walk in such all directions. That's why it comes late. See how many turnings it has to take. Violet, high energy, high energy. Yeah, so I will end my thing. And in my playlist, in my channel playlist, I have kept in all subject wise. You click on the playlist of my channel, so you will get subject wise and go on watch them. Right? And thank you.